Hi everybody. So in this section we're going to review factoring. So in the first example we're just going to review the basic types of factoring. Okay, then we'll do a more complicated example, and in the very end of the section we'll get to the only new type of factoring that we're going to see in this class. Okay, so this type of factoring, we have a trinomial, meaning there's three terms, okay, and we have something that's quadratic, right? We have y squared, okay? We also have that the leading coefficient is 1. We have a 1 in the front here. So when that's the case, okay, we know we're going to factor into two terms. So what multiplies to y squared is y and y, okay? And then we're looking for two numbers that multiply to 12 and add to -7. So that's going to be -4 and -3, okay? So this is just the basic type of factoring trinomials with 1 as the leading coefficient. Okay, in part B, we can see that we still have a trinomial, three terms. Okay, it's still quadratic, meaning we have x squared, but we don't have 1 as a leading coefficient. Okay, we're still going to break it into two binomials. Okay, so we're looking for something that would multiply to 2x squared. So what multiplies to 2x squared? It has to be 2x and 1x. Okay, and then we want something that's going to multiply to -2. Okay, so our choices are, one of them is going to be positive and one of them is going to be negative because they're multiplying to a negative number. Okay, so my choices for pairs that multiply to 2 are either 1, I can do -1 and +2, I can do 1 and -2, I can do 2, -2 and +1, or +2 and -1. Okay, these are all my choices. Okay, and then you're just going to check which ones work. Okay, so I'm just going to start with the top one. Okay, so I'll do -1 and +2. Okay, and then I'm going to check this guess by multiplying. Okay, so I have 2x times 2 is 4x. -1 times x is -x. Okay, so the center terms add to 3x, and that's what you want. Okay, so that means this was a correct guess. Okay, just for example, if you had tried something else, okay, so let's say, for example, I had tried 1 and -2. Okay, remember this was my setup. Okay, 1 and -2, I would have had +1 and -2. Okay, this would give me 2 times -2, which is -4x. Okay, and 1 times x is plus x. Okay, so this would give me -3x, and you can compare it to here and say that this isn't right. Okay, so this is the guess and check factoring method that we use when we have a coefficient that isn't 1 in the front here. Okay, now this is a square, by the way. Oh, I'm sorry, it's a cube. Okay, so this is a 3. Okay, so we have 4 terms here. Okay, so we can see that this isn't a standard quadratic trinomial. Okay, so when we have an even number of terms like this, one way that we can factor is by grouping. So if you remember, you'll group the first 2 terms and the second 2 terms, okay, and you factor out their common factor. So the common factor here would be x squared, okay, and when I factor that out, from here I have 3x, okay, and here I'll just have 1 left. Okay, here you can see that there's no common factor between 3x and 1, so I'm just going to factor out a 1. Okay, now you can see I have this common binomial, so I'm going to factor that out. Okay, and then I'm going to say what's left. So what's left from my first group is just x squared, and what's left for my second group is just 1. Okay, so that's a little review of factoring by grouping. Okay, The last type of factoring is this difference of squares. Okay, you can see this is x squared minus 2 squared. Okay, so this has the form a squared minus b squared. Okay, we know that this is going to factor as x plus 2, x minus 2. Okay, and in general, these special difference of squares always factor as a plus b times a minus b. Okay, just a quick reminder that the ordering of the factors doesn't matter. So if you had x minus 2, x plus 2, that wouldn't really matter. Okay, let's look at a more complicated example. Okay, so our directions are still to factor completely. Now, whenever you're factoring something and you don't know what type of factoring it is, the first thing you want to do is look for common factors. Okay, so I can see in this term and this term, I have the common factors of 4, x, and z. Okay, so the first thing I'm going to do is factor that out and see what's left. So if I factored out 4x and z, I only have x left. Okay, and here I factored out 4x and z, I only have 2 left. Okay, so this is actually all you can do to factor this one because what you're left with doesn't factor any further. Okay, so remember when you are factoring, the first thing you want to do is check for common factors. Okay. Part B illustrates a quadratic trinomial where the terms are out of order. Okay, if you see this when you're factoring, it's always easiest to put the terms in the correct order. Okay, and then factor them. So we have 1 as our leading coefficient, so we know we're going to have x and x. Then I'm looking for two things that multiply to -6 and add to -1. So that should be -3 and +2. Okay, you can always check your answer by multiplying this out. All right. Now here's something that we can see. We do have a trinomial where there's 3 terms, okay, but we're not sure how to factor it immediately. Okay, so we're going to go back to the wisdom of part A and look for common factors here. Okay, so you can see that there's a common factor of 3 and a common factor of n squared. Okay, so we're going to factor that out and see what's left. If I factored out 3n squared, I'm left with n squared. If I factored out 3n squared here, I'm left with -2n. And if I factored out 3n squared here, I'm left with 4. Okay. So now I'm looking for two numbers that multiply to 4 and add to -2. Okay. So the only factor pairs that multiply to 4 are 1 and 4, okay, or 2 and 2. Okay, and we actually know the signs because if they multiply to a positive and add to a negative, they must both be negative. Okay, so if you add these together, you're going to get -5. That doesn't work. You add these two together, you're going to get -4. That doesn't work either. So what this means is that this polynomial is factored already as much as possible. Okay. All right. So let's look at part D here. You can see that this is the difference of squares, so we're going to factor it this way. Oops. I actually wanted to do a slightly different problem. Okay, it's still the difference of squares. Okay, this is x squared squared minus 4 squared. Okay, so this is going to be x squared plus 4, x squared minus 4. Okay, now you may think, okay, factored as the difference of squares, we're totally done. But if you look at this factor, okay, this is still the difference of squares. So we can factor this even more, right? This is going to be x plus 2, x minus 2. Okay, now if you look at this factor here, This is not the difference of squares. This is the sum of squares, okay? That never factors, okay? And so we're gonna leave it like this because there's no other way to factor this, okay? Let's do our very last example from this, okay? Okay. So we're going to start by saying, okay, I have a 3 in the front, so my factors are going to start with 3x and 1x. Okay. Now I have that my second terms are going to multiply to a positive and add to a positive, so they must both be positive. Okay. And then there's only one thing that multiplies to 1, right? There's only one factor pair that multiplies to 1. It's just 1 and 1. Okay. So I'm going to check this by multiplying it out. I have 3x times 1, which is 3x. And then I have 1 times x, which is x. Okay. This gives me 4x. Okay. But that is not what we wanted here, right? We wanted 7x. So that means this doesn't work. Okay. Because there were no other choices, we don't have anything else to check. If we were in a situation where there were lots of things to guess and check, we would have to check each one of them. Okay, so what does that mean? Okay, if our only possible set of factors doesn't work, okay, that means that this does not factor. Okay, and I will tell you the word for a polynomial that doesn't factor is the same word that we use for a number with no factors. It's prime. Okay, so you want to make sure if you have something that doesn't factor, you're using the word prime to describe that, meaning that this has no factors, rather than saying I'm not sure how to factor it. Okay. All right. So let's look at our brand new type of factoring for this class. Okay. We're going to look at something of the form a cubed minus b cubed, which is called the difference of cubes. Okay, so there's a formula for how this factors. Okay, so this is going to factor as a minus b, okay, times a squared plus ab plus b squared. Okay, we also have the sum of cubes. Okay, and unlike the sum of squares, this actually does factor. Okay, so this factors as a plus b times a squared minus ab plus b squared. Okay, you can see that the difference between the two is the signs. This has negative and then positive. This one has positive and then negative. Okay, the sign from the first factor matches the sign from the original polynomial, which is how I remember it. Okay, let's do an example of using this. Okay. All right. So this is the difference of cubes, right? We have x cubed minus 3 cubed. Okay. So we're going to use our formula. So this is going to factor as x minus 3 times x squared plus x times 3, okay, plus 3 squared. Okay, this is exactly this formula with our a being x and b being 3. And the only thing I'm going to do to simplify, okay, is to write these terms how we normally would write this, which is 3x, okay, and then to say that 3 squared is 9. Okay, let's look at another one. Okay, So this is the sum of cubes. This is x cubed plus 2 cubed. Okay, so this is going to factor as x plus 2 times x squared plus x, minus x times 2, okay, plus 2 squared. Okay, and again, I'm going to simplify this part. So I'll have x plus 2 times x squared minus 2x plus 4. Okay. When you're factoring, these leftover parts will almost never factor. Okay, so you should quickly check that they don't, but they almost never do. Okay, let's look at a more unusual example of those. Okay, so this is still the sum of cubes. This is 2x squared cubed plus 3 cubed. Okay, so we're going to still use the formula with our a being 2x squared and our b being 3. Okay, so this is going to be 2x squared plus 3. Okay, and then we're going to have a squared, so 2x squared squared. Okay, minus ab. Okay, okay, plus b squared. Okay, so now we're going to simplify this part. Okay, so 2x squared squared is going to be 4x to the 4th. Okay, here I'm going to have minus 6x squared plus 9. Okay, and let's do one more example. Okay, now we can see that this right away is the difference of cubes because this is 2x cubed minus 4y cubed. Okay, but before we even do that, okay, we're going to look for common factors here. So even when you're doing the sum and difference of cubes, don't forget about common factors. So these have a common factor of 8. Okay, and once I factor that out, I still have the difference of cubes. So this is x cubed and this is 2y cubed. Okay, so I'm going to have 8 times, so my first factor would be a minus b, so it's going to be x minus 2y. Okay, and my second factor is going to be, I forgot to put my 8 out here. Okay, is going to be a squared plus a times b, okay, plus b squared. Okay, so all I'm going to do is simplify this. Okay, so here I'm going to have x squared plus 2xy, okay, plus 4y squared. Okay. All right, I hope that refreshes your guys' memory about factoring, and I will see you soon.